Tēnā koutou, welcome to this next video in the Redox 2.7 series, where we're looking at balancing full equations. So in the previous video we looked at balancing half equations, and now we're going to put the full equations together. So we've got another 4 steps that we need to follow to balance full equations. So first of all, you balance the half equations, which you need to watch the previous video to find out how to do that. Then, once we've got the half equations balanced, we need to find an integer or a whole number that you can multiply each half equation by to balance the electrons. So that could just be 1, or anything higher than 1. So if one equation's got 5 electrons and the other one has got 2, then you would need to multiply the equation with 2 electrons by 5 and the equation with 5 electrons by 2, so that both half equations would have 10 electrons. And then the next step is that we need to combine both half equations and cancel out the electrons and any other species that are the same on both sides of the equation. So that's the reason that we need to multiply both half equations to get the same number of electrons, is that ultimately we want to cancel them out. And then we need to, once we've done that, check that the charges and atoms balance in your final equation. So this is something that I'm a classic for, is just ploughing ahead and then finding that I've made a mistake a little bit too late in the final one because I haven't multiplied or something like that. So it's important to do the final check that you just haven't missed out a number anywhere. So we'll do an example. So this is I minus plus NO2 minus goes into I2 plus NO. So that's the full unbalanced equation. You can see that we don't have the charges balanced and the number of atoms on both sides are not the same. So we need to balance the half equations first. So we'll look at the half equations here. Half equations, I've done a little title there, but we won't actually see it. So we've got I minus goes into I2. So to balance this half equation, we need to make sure that each side of the reaction has the same number of atoms. So in this case we don't have oxygen or hydrogen atoms, but the non-oxygen or hydrogen atom is the iodine atoms. So we've got 2 iodine atoms there and 1 iodine ion there. So we need to have 2 iodide ions. And so we've now got a total charge of -2 on this side of the equation and a total charge of 0 on this side of the equation. So if this is 0 on this side, this is -2 on this side. The more positive side is actually the 0. So to bring that down to -2, we need to add 2 electrons. And then that's all balanced. So we've done that half equation. Here we've got the non-oxygen and hydrogen atoms are the nitrogens, and they are balanced. There's 1 on each side, so that's fine. The next step is that we need to balance the oxygens. So we would add a water here, H2O, and then we're going to end up, we will need 2 hydrogen ions on that side. Oh, getting a bit messy, sorry, 2 hydrogen ions. And so now we've got all of the atoms are balanced, but what we need to do is balance the charges. So this side is +1 overall because we've got 2 positives and 1 negative. That side is 0 because none of those molecules have got a charge. So we're going to need to add 1 electron onto that side of the equation. So we've now balanced the half equations. We need to add them together. So looking at our, I think it was the third step, is that we need to multiply, or the second step, sorry, we need to multiply these half equations by an integer that will allow the electrons to equal the same number. So what I'm going to multiply them by is, I can multiply this by 1, so effectively keep that the same. And if I multiply this half equation by 2, then I'm going to choose a different color here. I'll choose red as the multiplication one. So if I multiply this by 2, keep that all the same, then I'm going to have 2 NO2 minus ions, 4 H plus. I'm going to have 2 electrons, 2 NO, and 2 H2O. And so what I need to do now is that I can add these together. So you can see the electrons, we've got 2 electrons there, 2 electrons there, so I can cancel those out. Everything else on both sides of the equation is different, so there's going to be no more cancelling of any other things on either side of the equation. So to put it all together, I'll do this in black. We're going to have 2 iodide 2O minus plus, so that's everything on the reactant side of both half equations, so 2O minus plus 2NO2 minus plus 4 hydrogen ions plus goes into 1 iodine molecule plus 2NO, so it's a bit tedious, plus 2H2O. Does that all fit on the screen? Yes. So that's it. And now we need to check that we haven't made any mistakes. So we've got 2 iodines there, 2 iodines there, that's all good. 2 nitrogens there, 2 nitrogens there, very good. 4 oxygens, and we've got 2 oxygens there, 2 oxygens there, so 4 on that side, so that's all good. 4 hydrogens, and we've got 4 hydrogens within both those water molecules. The charges, we've got a charge of 4 minus plus 4, so overall the charge of 0 there, and then no charges on this side of the equation because there's no ion, so overall the charge of 0 there. So we're all good. We have balanced that full equation. So you can find a worksheet, or you can just try and put different half equations together to practice this. I hope you found that helpful. Like and subscribe for more chemistry videos. See you next time.